A very good day to all. I'm going to show you how to do the simulation for example 5.1 and 5.2. So first of all, you have to, as usual, you have to create a blank simulation. Then you have to list down all the components involved in the feed and also in the product. So we have hydrogen, nitrogen, methane, argon, and also carbon monoxide in the feed. And ammonia for sure is a product. So just list it down before you shift to the property method. So if you click next, then you'll be guided to a property method. Here, as given in the question, you have to choose RKSBM to cater the high temperature and pressure process. So once you have done this, then you can just click next to generate the properties for all the components. So make sure if you want to shift to simulation tab, you have to make sure the results are available under the property tab. So now let's generate the results for all the properties of the component. Okay, now the results are available. Then it's time for us to shift to simulation tab. So under the simulation tab, the first page that you are guided to is, of course, is the main flow sheet. So you have to, if you don't have the model Padlet, then you call out the model Padlet. Then to put the required block, okay, for the process. So we have compressor followed by a mixer. And before entering the reactor, we should have E100 to heat up the reaction mixture. And after the reactor, we have S5 here, the reactor effluent. It will be cooled down using E101 before the reactor effluent is entering the flash drum to separate into off gas and also liquid ammonia. So here I'm combining example 5.1 and example 5.2, meaning that I'm going to include the splitter and also another compressor to close the loop, okay, to recycle the off gas back to the process. Okay. So of course, once you have included the block, then you have to connect the stream. Okay. And you have to change the name of the block and also change the name of the stream accordingly. Now the flow sheet is completed. Then if you click next, then you'll be guided to include the feed information. So for syngas, the temperature is 553.15 Kelvin and the pressure is 26.17, and the composition in terms of flow rate, kilomole per hour for the respective component is so given in the question. Just include it accordingly in the feed specification. So once you have included the feed specification, now it's time for us to include the block information. So we go back to flow sheet, or you can also click next, then you'll be guided to the block information. So the first one, I'm going to selectively show you the block specification because some of it or most of it you have actually learned it in the previous chapters. So for example, for compressor, so C100, so in the question it is saying that it's an isentropic compressor with a discharge pressure of 271.4 atm. Just include it accordingly. Mixer, okay, let's look at mixer. So mixer, the default setting is always there, but you have to make sure across the mixer there's no pressure drop. Make sure under the column of pressure it is 0. Okay. What else? The rest is actually quite straightforward. Okay, R100. So for R100, the reactor temperature and pressures are given in the question. And for the chemical equation, you have to include the correct or the balanced chemical equation. 1 mole of nitrogen will react with 3 mole of hydrogen, and it produces 2 mole of ammonia, and the fractional conversion is 0.4 of the nitrogen. So done for reactor. And okay, we go to the last block. We have is a splitter. I would like to show you the splitter. So under the splitter you have, of course, splitter is to split the of gas into purge and also S7 stream. So S7 will be recycled back to the process, while purge will be pushed out to remove the impurities. So here 1% will be purged out. That's why we set it in fraction basis as 0.01. Okay. So once this is done, then you can actually run the process. So you have error, you see results available with error. Why is it? Let's check the reason in the control panel. So under the control panel, okay, so it's saying that the solver did not converge. Okay, so as in our lecture just now, the problem of non-convergence may be due to first the convergence method, that means the numerical method used, and the second is the number of iteration used. Okay, so let's check the method used here is Westing method. Westing method is actually an appropriate method used in the process with recycle stream, especially when you have one recycle stream. Westing method is actually adequate. Okay. So the reason of the non-convergence due to inappropriate method is actually invalid, meaning it may be due to the number of iteration. But how to verify that? So we can actually go to the convergence folder. So under the solver we have the tear history. So here you can actually check the maximum error or the tolerance with the number of iteration. Okay? It's actually quite hard to check in the table. You can actually plot it, then you can see clearly. So let's plot it. So make sure the x-axis is for number of iteration and the y-axis is the maximum error or tolerance. So click OK. So this is the default plot. You can actually change the range for the y-axis accordingly so that you can have a more meaningful interpretation from the graph. So the grid interval must be changed first before you change the range. So minimum is 5,000, negative 5,000 as recommended. Maximum is 5,000. Okay, so if you change it accordingly, obviously when the number of iteration increases, the maximum error is actually reducing to almost zero. Okay. Meaning that if we can further increase the number of iteration, because the default one is 30 iteration, so if we can further increase the number of iteration, we may the process may converge. Okay, so let's try. We go to convergence folder. Under convergence folder you have option. So under option you have method. So here under the Westing method, okay, you have to change the maximum flow sheet evaluation to 50. Okay, change it and then you reset, then run it again, and now the results are available without error, meaning the reason of non-convergence is solely based on the number of iteration. Okay, so with this I think we have done for example 1, example 5.1 and example 5.2. I would like to stop here before we proceed to example 5.3. Thank you very much.